Now we will move forward to a BERT. So BERT is a bidirectional encoder representation from transformer. In the transformer we have seen that we had a two part, the encoder block and the decoder block. If you will combine the multiple encoders, that we call it as a BERT, and if you will combine the decoder part, that will be architecture of GPT. So in this bidirectional encoder representation from transformer, we are combining the multiple encoder from the transformer. That was the way to create a BERT. So application of the BERT is a question and answering. You can ask a question, based on the learning it will going to generate the answer. How exactly it does, I will going to explain you. We can do the sentiment analysis also, like finding out the sentiment of a particular text. Is it neutral or negative or positive? That sentiment analysis we can do with the help of BERT algorithm. We can also perform a text classification and name entity recognition. So these are the application we can build with the help of BERT. Building this application requires a language understanding. So how we are going to train the BERT algorithm? So to do that, we have two techniques to train the BERT. First one is the pre-train BERT to understand language. Then we will going to fine tune the BERT to learn the specific task. First we will see that pre-training of BERT to understand language model. Pre-training the BERT to understand language. First one is a masked language modeling, and next one we are having a next sentence prediction. Both way we have to perform on the BERT to understand this language. What exactly the masked language modeling is? We will going to mask some words in that sentence. So model will going to try to predict those words. What should be present over here? What should be present over here? It will going to try to predict. When it will going to predict, we will going to calculate the loss function with the help of actual versus predicted. The model will going to run till it will achieve accuracy, or the loss will be nearest to 0 or equal to 0. So after doing that, next one is a next sentence prediction. What exactly it is? Means we have a two sentence in the paragraph. Sam is a YouTuber. Next he explains Gen AI. So it will going to tell that does this second sentence follows the first sentence or not. So that was the motive do next sentence prediction. Over here it will going to classify, yes, sentence B follows sentence A. So after doing these two ways, it will going to learn the language. Next we will see that how to fine tune the BERT. To fine tune on a specific task like a text classification, sentiment analysis, we have to fine tune the question answer. Means the dataset will be, one is a question, other will be answer. So on that dataset it will going to train. So this is the question and the passage, both will be feeded, and this is the extra layers will be added on that BERT algorithm. This is the algorithm which only understands the language, and the extra layer we have passed, these layers will be learned from scratch on that specific task. We are going to fine tune only the previous layer, means the language understanding layers we will going to fine tune, and this layer we will going to train from the scratch. So that's how the fine tuning of BERT work. Now we will see the variants of BERT. We have around 5 variants of a BERT algorithm. First is the robot. In this robot model, which is the version of a BERT model, in which only things is different is that we are using a large training data set, and the training duration is going to be quite longer as compared to the BERT model. And also we are doing the dynamic masking rather than static masking. So in the digital BERT, we have a 40% fewer parameters than BERT, and speed runs 60% faster than the BERT model. So performance retain around 97%. So this digital BERT is a quite smaller, faster and cheaper version of the BERT. That's the only difference between the BERT and the digital BERT. Next we are having Albert. So in case of Albert, we are sharing the parameters across the layer to reduce the model size, and we are doing the factorized embedding, means splitting the embedding matrix into a smaller matrices to improve efficiency. And here we have a tiny BERT, which is also a version of a BERT. It is the compressed version of that BERT, applies both knowledge distillation and the data augmentation techniques. The size of this model is quite smaller, and it's really faster than BERT. At last we are having a span BERT. So span BERT is a variant of BERT. While BERT focus on understanding the meaning of individual word in a sentence by predicting masked word, span BERT goes step further. So span in the span BERT refers to a continuous sequence of words. over there it will going to mask the not only one word, it can be two or more words together. So that's way it will going to capture the more meaning of that sentence. So that's why span BERT is better than BERT. So that was the difference. In BERT only we masked one word, in the case of span BERT we masked multiple words together.